Hello, everyone. My name is Jillian Stugard, and I'm here to talk to you today about problem solving. How do we solve these big word problems that were given in our class and for homework? And I'm going to introduce you to a 4-step process that you can use for each and every word problem that we're going to encounter. So I hope this is helpful, and let's get started. So let's talk about the map. For each word problem that we're going to problem solve throughout this semester, we can use a 4-step map that will take us from the problem to our destination of the answer. And what do those 4 steps look like? So the first step you always want to do is to identify. And what are you identifying? All variables, which are your unknowns, constants, which are your known numbers, and you always want to give those variables a smart label. So for example, if we were talking about length, we might use the letter L because length starts with L. So we immediately know what our variable is referring to. And we're also going to assign units to each variable and constant. So if we're talking about length in feet, we would assign the units feet. The second step is to translate. And what are we translating? Well, we're translating English sentences to the language of mathematics. What does this mean? We're going to translate our requirements into expressions, equations, and formulas. Our constraints are going to become inequalities. And our main goal at this step is to build a system of equations. You want to make sure that the number of variables you have in your system of equations is the same as the number of equation in your system. So if you identified, 2 variables, you want to make sure that you have 2 equations in your system of equations, which will move us into the third step of solving. When we are at this step, we're going to make a substitution so that we are solving for only one variable. That is incredibly important. And then we're going to use algebra to solve for that one variable. And then at our last step, we're going to check. What do I mean by that? Well, we want to make sure that our answer is a common solution and that it makes sense in context of the problem. So whatever variable we solve for in step 3, we're going to go back and plug that solution in to solve for all the other variables in our system of equations, and then we're going to check to make sure that the math did indeed work. So we're going to go through and break down each of these steps one by one in much more detail. Let's go. Here's our problem. This problem is straight from our workbook. It's from page 35 of my workbook. It might be a different page in yours because there are different versions of this workbook, but the workbook is called Algebra with Models, and it is by Marian Anton and Karen Santoro. So let's read our problem. The Sunny Days apartment building has a cylindrical above-ground pool in the yard. The diameter of the pool is 6 times its height, and the volume is 2,576.5 cubic feet. How deep is the pool? Now, when I'm given a word problem, I like to read it 3 times. The first time, I just like to read it. The second time, I start thinking about keywords that pop out at me, like the word cylindrical. So I'm picturing a cylinder in my mind, a cylindrical pool. The diameter of the pool is 6 times its height. So I know that the diameter and height are related, and that's going to have to be something I translate in the second step. I know the volume. The volume is 2,576.5 cubic feet, and I'm noticing that the units there, cubic feet. So when I am calculating my height and my when I'm talking about my diameter, all of those things should be in feet, right? And then the third time I read this, I really want to focus in on the question. So this is asking me how deep is the pool, which means I'm solving for the depth, or you can also think about it as the height, because they did use that word, but they're the same thing in this problem, the depth and the height, okay? So this leads us into step 1, identify. What are we identifying at this step? We are identifying the variables, our unknowns, and of course our constants, which are the numbers that we already know and were given in the problem. We're going to assign them each a smart label. So for example, if we're dealing with length, we would probably give it the smart label L. And we're going to assign units to each variable and constant. That's very important. Sometimes in a problem, you might be given two different units. For example, you might be given feet and inches. And you're going to have to really take a step back and realize, oh, I need to convert from either feet to inches or inches to feet because my units are different. So you really want to pay special attention to units in this step. You want to make sure you know what units you're dealing with and that they're consistent, the same. So let's think about the problem we were given. On the left side of my table, I've listed the variables, and on the right, I've listed the constants. If you look on the left side of my table, I have two variables, diameter and height. I do not know them. I was not given values for these in my problem. They are variables. They are unknown. So diameter, I've given the smart label D for diameter, and the units I was given in this problem are feet. I want to remain consistent, so I'm going to calculate my diameter in feet. I have the variable height. I was not given a measurement for height, so it is unknown. I'm giving it the smart label H, and I'm going to keep my units feet for that. I want to always be consistent. If you look on the right side of my table, I've listed the constants that we have here. Now, right away, when we read our problem, we saw a number that popped right out at us, 2,576.5, and that represented the volume. So I've given the volume the smart label V. There's its value, 2,576.5. And that was given to us in cubic feet. And a volume is always cubic whatever, cubic feet, cubic meters, because we're multiplying three things together. Now, you might not have realized it at this step, but I am going to point out that we also have another constant, the constant pi. And the reason we have the constant pi is because our pool is in the shape of a cylinder. When we calculate the volume of a cylinder, we are multiplying the area of a circle, right? The base of a cylinder is a circle times the height. So the area of a circle, the formula for that is pi r squared. So we are going to have pi. If you didn't realize it in this step, that's okay. You would have realized it in the translation step when we started talking about the formulas that we needed. But I just want to point that out here, that pi is a constant. And we don't assign it units because when you use it in your calculation, your units are whatever you were working in to begin with. So we were working in feet. So that moves us into step 2, the translation step. So now we need to translate. What exactly are we doing at this step? Well, we're translating English sentences into the language of mathematics, which means we're taking our requirements and turning them into expressions, equations, and formulas, and we're taking our constraints and turning them into inequalities. We do not have any constraints in this problem, so we will not have any inequalities, but it is worth pointing out and thinking about. So we are going to take those sentences from a problem and turn them into math. And at this step, you want to build your system of equations. So at the end of this step, after you translate everything, you're going to have some sort of system of equations. Now remember, I said that the number of variables should be the same as the number of your system of equations. Well, how many variables did we identify in step 1? We identified 2. We identified the variable of the height and the diameter, right? So we want to wind up with 2 equations when we build our system in this step. So let's take a look. So like I said, you should have the same number of equations as you have variables in your system. We have 2 variables, so we're going to want 2 equations. Let's translate. The first sentence I'm going to deal with in our translation is the diameter of the pool is 6 times its height. Right? 6 times. That means we're multiplying by a factor of 6. And what are we multiplying by a factor of 6? Well, the height. Okay? When you see the word is in a sentence, it says the diameter of the pool is, that implies equality. So we're saying that the diameter is equal to 6 times the height. And you can see I've now taken that sentence and translated it to D equals 6H, right? Using my smart labels, the diameter is equal to 6 times the height. Now, I also really need to think about the volume. I was given a constant for the volume. I was given what the volume equaled, 2,576.5 cubic feet. Well, I need to translate that value to the formula that it came from. So what is the formula for the volume of a cylinder? Well, it's the area of its base, which here is a circle, multiplied by the height, the third dimension of height. So the area of a circle is pi r squared, and h was our height. So the volume here equals pi r squared h. I chose this problem for a reason, because there was sort of an extra trick in translating this formula. Notice how the formula for volume is given in terms of the radius, pi r squared. Well, here you really have to think about what radius is. Radius is half of the diameter, okay? It measures from the midpoint of a circle to any point on the outside of the circle. The variable we were given was diameter. So we need to think, ooh, I need to replace radius with diameter divided by 2, because the radius is the diameter divided by 2. So you'll notice that I've rewritten it instead of pi r squared h to pi quantity diameter divided by 2 squared h. I've just replaced the r with the diameter divided by 2, because radius is diameter divided by 2. So I need to plug that in instead of r, because here we named our variable diameter. We did not use the variable radius. So I need to make sure that I'm writing things in terms of the variables that we've chosen, and diameter was one of the variables that we chose, okay? So my volume is going to equal pi, quantity diameter divided by 2 squared times h, and that equals, we already know, 2,576.5. That's what our volume equaled. So pi d over 2 squared h should equal 2,576.5. I now have my system of equations. My first equation is diameter equals 6h. My second equation is the volume equation, which is 2,576.5 equals pi times the quantity diameter divided by 2 squared h. Okay? Do I have two equations? I do. I have two variables, d and h, so I should have two equations, which I do. That's very important. So I wanted just to take a quick minute to show you that sometimes at step 2, the translation step, it's really helpful to draw a picture. If you're a visual person like me, it's very, very helpful. But it also really just helps to make things a little bit more clear. So sometimes it really does make a difference to take an extra few seconds to jot a quick picture down on your paper. And I think it's particularly important for this problem because we had to replace that r from our original volume formula, that pi r squared times h. We needed to replace the r that was standing for radius with d over 2, diameter divided by 2. And you can clearly see if you look at the bottom of this picture that diameter is the entire length, whereas radius is half that length from the center of the circle to the outside. So this problem was given to us in terms of diameter. So we want to stick with diameter. We've labeled diameter as our variable. So we replace that r with diameter over 2. And that way we don't have this extra r variable floating around. Now everything is in terms of the variables we've already chosen. And this picture also helps us to see that the height is the same as the depth of the pool, because they asked us for the depth of the pool, but they worded it in terms of height. So you can see that they're equivalent. So this picture is really helpful. So now we can move into step 3, which is to solve. And the really important part about this step is figuring out how to make a substitution. We're going to substitute one or two or more variables into one of our equations so that we're left with only one variable to solve for. So you're going to try and substitute in such a way that you are left with just one variable. And that's really important because when you solve something algebraically, you only want to be solving for one variable. So how do we do this? So like I said, we're going to make a substitution using the equations from our system of equations that we just built in our previous step. And in order to figure out what kind of substitution to make, we're going to ask ourselves, which equation encompasses all of the others? Which equation deals with all of the variables and constants that I identified in my first step? And that's the equation we're going to substitute into. And when we make our substitution, again, whether we're substituting for 1, 2, 3 variables, we should only be left with one variable at the end to solve for. Once we have our one variable, we're going to solve using algebra. We're going to actually solve and find a value for that variable. So Let's solve. Here's our system of equations that we just built in step 2. We have that the diameter is equal to 6 times the height, and then we have our volume, which is 2,576.5 equals pi times the quantity of the diameter divided by 2, which was representing our radius, squared times the height. Now we're going to look at these equations and we're going to ask ourselves, which equation encompasses everything, our variables and our constant? And the only equation that satisfies that is the second, right? It gives us our constant value that we had for our volume, and then we also see both of our variables, d for diameter and h for height. So this is the equation that's sort of going to unlock things for us. So what we're going to do is we're going to take that first equation, diameter equals 6 times the height, and substitute it in to the second equation. We can do that because look at our second equation. We have the variable d in there, in those parentheses. We have diameter. So we know what diameter is. Diameter equals 6 times the height. So anywhere we see a d, we can substitute in 6 times the height, 6h. So we're going to substitute d equals 6h into the second equation for the variable d. So now our new equation after our substitution looks like this. 2,576.5 equals pi times the quantity of 6h over 2 squared times h. We took our d equals 6h and we substituted it in for the d in our volume equation. So now instead of d over 2, we have 6h over 2. And now we only have one variable, which is exactly what we are trying to accomplish. We are only solving for h now. We have one variable, so we can use algebra to solve for that variable. And I'm going to continue and show you the algebra on how to solve for h in the next slide. Remember, when we solve for a variable, we want the variable on one side and everything else on the other. So we need to isolate h. Let's solve for the variable h using algebra, okay? I've highlighted the variable h so it pops right out at you. The first thing we're going to do to solve for that is to square 6h over 2. We want to square that quantity, right? If we're thinking about order of operations, we need to deal with the quantities first. So I need to square that to see what I'm working with. So the 6 squares to 36, the h squares to h squared, and the 2 in the denominator is going to square to 4, okay? Now I'm going to multiply by h. I'm going to combine my like terms, which leaves me with 2,576.5 equals 36h cubed over 4 times pi. Okay, I need to get rid of that 4 in the denominator, so I'm going to multiply both sides by 4. Once I do that, I can now divide both sides by my constant terms, 36 pi. And now I'm left with 91.125 equals h cubed. And I've been rounding. Okay, you guys, I've been rounding as I've been doing these calculations. So now I want to take the cube root because remember, I want to solve for h, which means I want h on one side, everything else on the other. How do I get rid of that power of 3? Well, I take the cube root on both sides, which leaves me with h equals 4.5. Okay, and what are we dealing with? 4.5 feet. So the height of the pool is 4.5 feet. That's important. I've just solved for the height. So now I've done all this work. My brain is probably super tired and I've probably forgotten what I was even trying to do in the first place, which leads us to step 4. We need to check. This is such an important step. You need to make sure that we plug our solutions back into the other equations from our system of equations in order to solve for the other variables. Remember, we had 2 variables. We had diameter and height. We've only solved for height, so we're going to need to solve for diameter. And then we need to make sure that it all makes sense mathematically. So we're going to plug h equals 4.5 into our first equation to solve for diameter, okay? Because remember, we have height, but we don't have diameter yet. So if we plug that in, we just plug in 4.5 wherever h is. So we have d equals 6 times h, which is equal to 6 times 4.5, which gives us a diameter of 27 feet. Now we need to make sure that our math worked. So we need to make sure that when we plug in our height and our diameter, that we get the volume out that we were given. So our volume should be 2,576.5 cubic feet. We were given that, right? So let's plug h equals 4.5 feet and d equals 27 feet into our volume formula to make sure it checks out. And if we do that, we do indeed get back 2,576.5 cubic feet. Okay? I just plugged in 27 where D was, 4.5 where H was, and I calculated it out, and that's what I got. So our final answer is that the pool is 4.5 feet deep, right? We were asked what is the depth of the pool. Depth is the same as height in this problem. So our variable H was 4.5, which means our pool is 4.5 feet deep. And always circle your answer for me so it's really clear as to what your final answer is. So what did we learn today? Well, we learned that there are 4 steps we can take to solve any and all problem-solving word problems this semester. The first is to identify your variables, constants, assign them a smart label, and units. The second is to translate from English sentences to mathematical equations and to build a system of equations. And the third is to solve using a substitution, solving for only one variable. And then you need to go back and check. So check and solve for your other variables, your other unknowns, and make sure that the answer you are given makes sense in context of the problem and in terms of your system of equations. I know that these are difficult. These require a lot of practice. So it is really important for you guys to make sure you are building in time to do your homework, to pull extra problems out of the workbook, to go to the algebra lab, to ask questions in class, to do a lot of examples of these, because you will not feel comfortable until you have. And that's okay. Learning any new skill takes practice. It shouldn't be easy the first time. And I know that that can be difficult. But if you tell yourself, perfect, I can do this. This is a chance for me to grow and to learn. And if you practice, you will get to the point where it will become automatic. Okay, first I identify, translate, solve, check. Identify, translate, solve, check. So this map is just meant to help you in thinking through each and every step and the logic of solving these problems. Keep practicing, keep asking questions, keep reaching out if you need, but practice until you've got it, okay? I know you can do it. Well, good luck, you guys, and have a lot of fun.